Okay, let me start from the beginning. Okay, hello students and welcome to today's Friday Happy Math Hour. What I'm going to cover today is the exam exam 3 review. I believe the exam is scheduled for next week, which is good because this way it can prepare you for for the exam, which most of you guys will be taking next week. Okay, these are the topics that I'm going to cover. This exam covers everything from chapter 6, which is 6.1, 6.2, 6.3, 6.4, 6.5, and 6.6. Okay, 6.1 is systems of two linear equations and two variables. So let's start with that topic for section 6.1. Okay, the first thing that students must understand is that they can check their work when they get the answer by actually plugging in the point that they got for the answer, plugging back into both equations. So this is how you can apply this concept here. Determine whether the given order list of numbers is a solution of the systems of equations. So for number 1, we have the point -1, 3, and see if it's a solution for these two equations. So I'm going to call it equation 1 and equation 2. So I'm going to plug in -1 for x and 3 for y on both equations. Okay, so if I plug in -1 for x and 3 for y, we simplify on the left side of the equal sign. So it's going to give us -2 plus 3. So this gives us 1 equals 1. So it works for equation 1. So if it works for equation 1, then you proceed to equation 2. And say, for example, that it wasn't true on equation 1, then you stop there because the point has to be true for both equations. Okay, now let's continue to equation number 2. And we're going to do the same thing. We're going to plug in the same point, which is -1 for x and 3 for y. After we simplify the left side, it's going to give us 3 plus 6, and 3 plus 6 equals 9. So 9 equals to 9. That means that the point -1, 3 is a solution to the systems of equations. Okay, let's do number 2. Okay, but number 2, we have two different equations, equations 1 and 2, right? Again, but the point that's being considered is 2, -0.5. And again, I'm going to repeat the process as before. I'm going to plug in the point to both equations. So x is 2 and y is -0.5. After I evaluate the left side, it's going to give us -3, right? So -3 does equal to -3. So then we can proceed to equation number 2. Okay, x is 2 and y is -0.5. And again, after we evaluate the left side, it's going to give us -0.5. Does -0.5 equal to -5? No, it doesn't. Which means that the point 2, -5 does not make both equations true, and the order pair is not a solution. So for number 1, it was a solution. For number 2, it was not. Okay. Now we're going to be solving the system by graphing. I believe in this section 6.1, it doesn't want you to solve it by graphing. They want you to do it by substitution and also the elimination method. But I want to show you that there's other ways to solve the system also by graphing. So at first, we're going to graph it. Okay, we're going to graph both equations. And this can also give us practice to the topic of graphing linear equations, right? And this way, we'll see how this is applied for solving systems of equations. So equation 1 is y equals to 3x minus 6. My slope is 3, 1, right? And my y-intercept, which is a b, is going to be 0, -6. 0, -6 is my starting point, right? This is a review from, I believe, from the first chapter that we covered in 1324. So we're going to start at 0, -6. So we're going to start at 0. We're going to go all the way down to -6 for the y, which is a point right there. Now the slope is 3 over 1. So that means I'm going to go up 3 and 1 to the right. So from the point 0, -6, I'm going to go up 3. That's 1. That's 2. That's 3 and 1 to the right. And then I just draw my line connecting the 2 points. Then I'm going to graph equation number 2. Equation number 2, right, if we want to graph by using the slope-intercept form, is not in proper form. So I need to rewrite it. So I'm going to add 5x to both sides, which the result will give us negative 2y equals to 5x minus 10. Then I'm going to divide both sides by negative 2. That will give us y equals to negative 5 over 2x plus 5. So my slope is negative 5 over 2, and my b, which is a y-intercept, will be 0.5. And this is my starting point, 0.5. So 0.5 is way up here on the positive y-axis. That's my 0.5. Now I'm going to go down 5, and 2 to the right, because that's my slope is negative. So I'm going to go down 5, so that's 1, 2, 3, 4, 5, and 2 to the right, 1, 2. After that, I connect my 2 points, and that'll be my line. If you notice, the solution is where both lines intersect. So my answer will be 2, 0. Okay. Okay, now, on the next slide, I'm going to do the very same thing, but I'm going to do it by substitution. Okay. So solve the system by substitution. So here, guys, what you got to do when they give you 2 equations, you have to isolate either the x or the y. Okay, whatever is easier for the student. Since equation number 1, right, it's already isolated, the y, that's what I'm going to be using to plug in for the second equation. Okay, I know that y equals to 3x minus 6, right? So I'm going to substitute the 3x minus 6 for the value of y there, right? So I'm going to plug it in there. Then I get to distribute. So that's going to give us negative 5x minus 6, negative 5x minus 6x plus 12 equals to negative 10. Now I get to combine like terms on the left side of the equal sign. Negative 5x minus 6x will give us negative 11x plus 12 equals to negative 10. Now solving for x, I'm going to subtract negative 12 from both sides. And the result is going to give us negative 11x equals to negative 22. Divide both sides by negative 11. The result will give us 2. So x equals 2. Now, I need to find the y value, right? Because I already found the x part of the point. Now, I need to go to either equation 1 or equation 2 and plug in 2 for x and solve for y. So here, guys, it all depends what's easier for the student. In my opinion, guys, it's easier to go to equation 1 because equation 1, the y is already isolated or by itself. That means the work will be much easier. So I'm going to plug in 2 for x, right? And then I'm going to simplify the right side of the equal sign. So y equals to 6 minus 6, y equals to 0. So then that means that my x is 2 and my y is 0. So that's my solution. If you notice, we got the same answer as when we did it by graphing. Okay. Now I can also do it by the elimination method, but I'm going to show you two different equations to do it by the elimination method. So here for number 5, we're solving the system by the elimination method. Okay, one thing that you got to know for the elimination method, both equations must be in the form ax plus by equals c. Okay, so for example, equation number 2 is okay, right? Because it's 4x minus 3y equals to negative 1. But if you notice, equation number 1 is not in the proper form. So that should be my first step, is to rewrite it in proper form. So I'm going to add 2y to both sides, right? Because the x and the y are on the left side, and the c, the constant, is on the right side. So the negative 2y must go to the left side. So I'm going to add 2y to both sides. That will give us x plus 2y equals to 19. So equation 1 is already in proper form. So now here, here is where you got to eliminate either the x's or the y's. Okay, again, it's up to the student how they want to do it, because every student, or we all think different. Almost every student also thinks different. Okay, so it's up to the student what way they want to do it, if they want to eliminate the x's or eliminate the y's. Here, guys, if you notice, the x in equation 1, the coefficient is 1, right? So the x is already isolated. So it'll be easier to cancel the excess or to eliminate the excess, which means I need to multiply equation 1 by -4. Why -4? Because -4 times x will give me a -4x. And then when I add it to the second equation, the excess will be eliminated. Okay? But you have to use legal math concepts here. If you multiply the x by -4, you have to multiply the whole every term by -4, or both sides of the equal sign. When you multiply -4 times equation 1 on both sides, the result will be -4x minus 8y equals to -76. So then equation number 2, we just let it over. Right? Then after we add them, if you notice, the x's will be eliminated. So we can add -8y minus 3y will give us -11y. When we add -76 minus 1, the result will be -77. So now we divide both sides by -11. If we do that, the result will be y equals 7. So I got the value for y equals 7. And we did in the previous slide, right, on the previous problem. Now I need to find my x value, right? So I can go back to either equation 1 or 2, whatever is easier for you. Like in my opinion, it's easier to go to number 1. Why? Because the x is already by itself, it's already isolated. So I'm going to plug in 7 for y, and it's going to give us -14 plus 19. So x equals to +5. So what's my solution? 5, 7 is a point where to solve this system of equations. My solution is 5, 7. Okay, now let's do another one here. Okay, now here, what should we get rid of? The x's or the y's? These are almost the same, right? Because if we want to get rid of the x's, we multiply the first equation by -2. Okay, so that's what we're going to multiply the equation by -2. But if we notice here, -2 times 3x will give us -6, -6x, -2 times -2y will give us +4y, and -2 times 4 will give us -8. If you notice equation 2, everything's the opposite sign, so everything will cancel. When you find yourself in this situation with no x's or y's, it just means that if the left side equals to the right side, that means it's going to be infinite solutions. That means both of the lines are the same line. So the answer will be infinite solutions. Now, but what happens when the left side and the right side are not the same, right? Are not the same constants or the same values with no x's or y's? Here's what happens here. So I'm going to multiply the first equation by -3. By -3, so I can cancel the x's. They'll give us -6x minus 15y equals to -24. Now, after we do the operation here, it's going to give us 0 equals to -6. You see, if you notice, there's also no more variables, no x's, no y's, but the left side does not equal to the right side, which means that these lines are parallel. That means no solution. That's how you answer this type of a situation here. Okay. Hey guys, and the problems that I'm giving here, guys, as a review, I believe most instructors will give you some that are here. I cannot speak for every instructor, but I do give most of these on the exam, on exam number 3. Okay, I try to give them one of each. Okay, so expect something like this on your exam, or at least know exactly how to solve these problems. That way, if your instructor gives you something similar, you'll be able to answer answer correctly. Okay, now this is how you apply these type of problems in real life. Okay, this is number 8. It states a 200-seat theater charges $8 for adults and $5 for children. If all seats were filled and the total ticket income was $1,435, how many adults and how many children were in the audience? So this is how I approach this problem. I tell my students, you need to find 2 equations, okay? And I tell them, you're going to do seats with seats or people with people and money with money. What does that mean? Let me show you what it means. Okay, so we have, I'm going to do seeds with seeds. So we have 200 total seeds, right? There's going to be it's going to be adult seeds, right? And also children seeds. So we're going to let, since adults are first, I'm going to let X equals to adults. And I'm going to let Y equals to the children's. Okay, but we're talking about seeds, right? And there's a total of 200. So how do we get this equation? It's going to be X plus Y equals to 200. That's equation number 1. Now let's do the money with money. So, okay, we stated that that X represents adult tickets, right? Adult seats. So then adult tickets are $8. So this will be 8X. Now for the children's tickets are $5, right? And Y represents children. So this is going to give us 5. And what was the total revenue or the total income? Was $1,435. So here's what we get our second equation. 8X plus 5Y equals to 1,435. We have our 2 equations. Okay. Now you can solve it either by substitution, the elimination method. Again, in my opinion, because these are already set up in the form AX plus BY equals C, it's the easier. It'll be easier to use the elimination method. But if you prefer to use the substitution method, it's up to you what you want to use. Okay, but here I am going to use the elimination method. So here, guys, I have equations 1 and 2 correct. I want to get rid of the x's or eliminate the x's. So I'm going to multiply equation 1 by -8. So after I distribute the -8, right, it's going to give us -8x minus 8y equals to -1600. So equation number 2, we just slide it over. Then we get to add them. And if you notice, the x's will be eliminated. So we get -3y equals to -165. So we divide both sides by -3, and we get the value for y. Y is 55. Now, as we have, as we have been doing in the past 3 or 4 slides, we already got the value for the x for the y, right? In this case, we got the value for y. But now I need to go back and find the value for x. And again, in my opinion, it's easier to go to equation 1 because you see that the numbers are very, very small compared to equation number 2. So I know that y is 55. Let's plug in the value for y, and we solve for x. Subtract 55 from both sides, and I got the value for x. So what's my answer? X is 145, and y is 55, right? But that's not what they're asking for. They're asking for how many adults and how many children were in the audience. If you recall, we let x be adults, so it's going to be 145 adults and 55 children. That's the total number of each adults and children in the theater. Okay. And that covers everything for section 6.1. Now they go to section 6.2. This is larger systems of linear equations. Okay. For example, now we're going to have 3 equations with 3 variables each. So I believe when I covered this presentation about 2 weeks ago, I mentioned that I told my students to always follow this plan, and they can never go wrong if they follow this plan that I came up with for this certain situation here. I tell my students, you're going to get equation 1 and equation 2 and eliminate the x's. And then you're going to repeat the process with equation 1 and equation 3. Okay, but first, let's get rid of the x's on equation 1 and 2. So here, guys, I'm going to multiply equation 1 by -2. Again, why -2? Because -2 times x will give us -2x. Then when I add it to 2x on the bottom on the second equation, they'll be eliminated. So if I multiply -2 times every term on equation 1, this will be my result. -2x plus 6y minus 4z. So equation number 2, all we do is slide it over, and then we get to do the operation. So this is my result. 4y minus 3z equals to 3. I consider this my new equation 2. Okay, now I'm going to repeat the process, but I'm going to use equations 1 and 3, and again, I'm going to get rid of the x's or eliminate the x's. So in this situation, I'm going to multiply equation number 1 by negative 3. So after I multiply negative 3 times every term, the result is negative 3x plus 9y minus 6z equals to 0. Then equation number 3, all we do is slide it over, and then we do the operation. If you notice, the x's will cancel. So we have 10y minus 7z equals to 7. That's my new equation number 3. Now the next step, I'm going to get the two new equations, 2 and 3, and I'm going to eliminate the y's. Okay? So in this case, I'm going to multiply equation number 1 by negative 10 and equation number 2 by 4. I know that at times they say that they try to get the least common multiple for both, right? Which will make it the numbers not that big. If you want, it can be 20, right? Because the least common multiple for 4 and 10 is 20. But I always assume that students don't know nothing, guys. This way, whatever students might know, it'll be a bonus, okay? Because a lot of students have been out of school for a while, and once they come back, they don't understand certain things like what's the least common multiple and stuff like that. So that's why I try to present my workshops and presentations to target older students that have a hard time coming back to school, and it's kind of hard for them. So that's why my PowerPoints are meant for them, but also they're very useful for the students that actually just got out of high school. So in this case, I'm going to multiply equation 1 by negative 10 and equation 3 by 4. If you notice, guys, this is 410 and this is negative 10, 4, right? Because this way it guarantees that the y's will be eliminated, because 4 times negative 10 will give us negative 40, and 10 times 4 will give us positive 40. So that will be the elimination of the y's. But I need to multiply negative 10 times every term, and also 4 times every term. So after we do the operation, this is my result. So here, guys, I get to simplify. Here, I'm going to divide both sides by 2. So z equals to negative 1. You see, I found the value for z now. But I'm still need to find the value for y and the value for x. So here's we're going to be using back substitution. You see, I'm going to get equation 1 as a 1 from the beginning. Then I'm going to get equation 2 as a new equation 2. And then the equation 3 will be the value that we just saw for z. Now I'm going to go back and use the back substitution method. Okay, I'm going to go back to equation 2. We already know what z equals to, right? So if we plug in negative 1 for z, we'll be able to solve for y. Z is negative 1. There'll be 4y plus 3 equals 3. We subtract 3 to both sides. So we got 4y equals 0. Now we divide by 4. So we know that y is equal to 0. Now that I have my z and my y values, then I go back to equation 1, and I'm going to plug in 0 for y and negative 1 for z. That's my y, this is my z, and we simplify the left side. That gives us x minus 2 equals 0. We add 2 to both sides. So the answer will be x equals 2, y equals 0, and z equals to negative 1. That's how you solve these type of problems, guys. And again, like a recap of what we just did. When they give you 3 equations, right, it's always wise to try to put equation number 1 with a coefficient of 1, because this way all the work will be much easier. Then the second step is that you're going to get equations 1 and 2 and equations 1 and 3, and you're going to eliminate the x's. So you're going to get 2 new equations, new equation 2 and new equation 3. And if we notice, those 2 new equations, they don't have an x value or an x variable. So then you use the new equations 2 and 3 and you get rid of the y's. And after that, you're going to get something like z equals to something. And then you go back and substitute. Okay? That's to recap what we just did. That was number 9. Now, I believe I'm going to solve this method by using the Gauss-Jordan method. This method is a little bit more complex and challenging for students. But I believe how I present this type of problems, if you follow what's here in the workshop, I think it's going to make more sense to you. Okay. So again, this is the same equation as we did on the slide number 9, on the previous slide. Okay, we have to go from linear systems to augmented matrix, right? This is row 1. You see, and we notice we only get the coefficients on the x. That's 1, -3, 2, and 0. And then 2, -2, 1, and 3. And 3, 1, -1, and 7. This is called the augmented matrix. You're going from linear systems of equations to the augmented form. And then here's where you're going to be solving it. This is considered reduced row echelon form. That's what the RREF means. Okay. And then if you put in the calculator, this is your result. You see we got the same value for x and for y and for z on the previous problem that we did by doing it the other way. I believe later on this PowerPoint, I'm going to show you how to plug something like this in the calculator. Okay, so it's good to know how to use it, how to plug it in. This way you can check your work. But I always tell my students that they have to know, how to work it with showing all the work to get the full credit. So how is it done? Okay, here we go. I call it the 3-step plan in action. Okay, 3-step plan. So the first step, right, is our matrix. So I want to go to here. You see, guys, the blue is step 1, color coded. The 2 zeros in green is step 2, and the 2 zeros in red, that's step 3. So this is considered row 1, row 2, right, and row 3. So in step 1, I'm going to keep row 1. So row 2 is going to change, and row 3 is going to change, right? Because recall, these two must be zeros, so the 2 and the 3 here must be zeros, right, according to step 1. That must be a 0, and the 3 must be a 0. That's why I put the arrow right after the row number 2, because that was going to change, and also do it also for the bottom one. That was going to change. So we're going to use row number 1. So I'm going to multiply -2 times row 1 and add it to row 2. Then I'm going to multiply -3 times row 1 and add it to row 3. And here's my work. -2 row 1 is equal to -2. Now I'm going to multiply -2 times every term inside the parentheses. And this should be my result. Then if I add it to row 2, right, I just bring row 2 over. It's going to give us 0, 4, -3, 3. So that's my new row 2. Then I do the second part on step 1, right? So I multiply -3 times row 1. The result is -3, 9, -6, and 0. Then the row 3, we just bring it over. And then we execute the operation. It's going to give us 0, 10, -7, and 7. That's my new equation number 3, or row 3. If you notice, guys, this is the same thing that we did on the previous way to solve it, right? When we got equation 1 and 2, get rid of the excess, and 1 and 3, get rid of the excess. This is what we're doing, but we're not using the with the variables x, y, and z. We're using the augmented form of the matrix. Okay, but it's almost the same thing. Now on the next slide, I'm going to show you step number 2, which is color coded and with green. So I'm going to bring just this part and put it on the next slide. You see, there it is. Now step 2, right? Step 2 is in green. So for step 2, I'm going to keep row 2 how it is. So the -3 must be a 0, right? And also the 10 must be a 0. So that row 1's got to change. And also row 3's got to change. Okay, now, since row 1, right? So, but I'll be using row 2 to eliminate the -3 and also the 10. So since we already have a negative and a positive, I'm gonna multiply 3 times row 2 and add it to 4 times row 1. Okay. And here similar, right? I'm gonna multiply -4 times row -10 times row 2 and add it to 4 row 3. And here's my work. 3 row 2, right, is 3 times 0, 4, -3, and 3. So then, after I multiply 3 times every term, it's going to give us 0, 12, 9, and 9. I'm going to add it to row 1, right, to 4 row 1. So I'll multiply 4 times every term in row 1, and the result is 4, -12, 8, and 0. So after I execute the operation, the result is 4, 0, -1, and 9. That's my new row 1. Now for the second part, in step 2, I'm going to multiply -10 times row 2. You see, guys, I'm just doing what's here, right in the arrow. I'm going to do that part first. So if I multiply -10 times every term, the result is 0, -40, 30, and -30. Now I'm going to add it to row 3. But row 3, I have to multiply by 4, correct? Because this way, the 10 will, the 10 in the slot will be eliminated. After I execute the operation, this is my result. But like I always tell my students, to simplify as you go along to make it with the least amount of matrix as possible. So in this case, this can be simplified, right? I can divide everything by 2. If I do that, the result will be 0, 0, 1, -1, and that's my new row 3. Now I'm going to carry this over, just my work here. I mean, not the work, but just this part, and this part, and this part. I'm going to put it on the next slide and solve the parts for step 3. So for step 3, right, we're going to use row 3. Row 3 stays the same. So we're going to change row 1, right? So that's going to change, and we're going to change the third column in row 2. The -3 must be a 0. So now we're going to be using, right, row 3. If you notice, row 3 is already a 1 in the slot, right? And here's a -1. So all I'm going to do is add row 3 plus row 1. And here I'm going to multiply 3 times row 1 times row 3 and add it to row 2. And here's my work. Row 3 plus row 1 is going to give us 4008, right? And here, guys, we can simplify. We can divide everything by 4. So my result will be 1002. That's my new equation, or my new row 1. Now let's do 3 row 3 plus row 2. So 3 times row 3 will be 3 times 0 times 0 times 1 times -1, and the result is 0, 0, 3, -3. Add it to row 2. We just bring row 2 over. And then after we execute the operation, it's going to give us 0, 4, 0, 0. We can divide everything by 4, right? So to simplify, we divide everything by 4. It's going to give us 0, 1, 0, 0, and that's my new equation, or row number 2. If you notice, if you keep simplifying as I do it, guys, you're already going to have, you can do the work in 3 matrix, 1, 2, 3. I believe the book and how other tutors or instructors explain it, they do 1 step for each matrix, and at times you can have like 6, 7, or 8 matrix. And in my opinion, that's too much. So if you follow this method, you can do it in 3 steps, and at the maximum, maybe 4. Because if you will have fractions, then at the end, you multiply by the reciprocal to give you 1s all the way across. Okay? Anyway, that's my result, will be 2, 0, -1. Okay, now, let's solve this one together here, okay? I'm going to go and try to solve this. I'm going to try to solve this one. And this way, you have everything in one slide here, okay? So again, step 1, the two that I'm pointing at must be a 0 and also a -1 in row 3. So we're gonna keep row 1. So then the row 2 we're gonna eliminate the 2 and on the second row, first column, and also the third row, first column, these two must be zeros. So I'm going to multiply -2 times row 1 and add it to row 2. Then since this is already a +1 and a -1, all I have to do for this step is add row 1 plus row 3. And here's the work. Okay, step 1, -2 row 1 plus row 2, we have -2 times row 1. So after I multiply -2 times every term in row 1, it's going to give us -2, -4, 2, and -12. Plus row 2, all we do is slide row 2 over. Then it's going to give us 0, -5, 5, and -10. If we notice, right, we can divide everything by -5 because all these can be divided by -5 and it won't give me a fraction. So we can simplify it with go along to make our work much easier. So this is my new row 2, 0, 1, -1, 2. Now I'm only going to add row 1 plus row 3 to give me the 0 on the third row, first column. There's my result. So we're going to get 0, 1, 0, 1. That's my new row number 3. Now step 2, right, step 2, we keep row 2. So the 2 on the first row, second column must change. And also the 1 on the third row, second column must also change. So again, we have to use row 2, right, to eliminate the 2 and the 1. So I'm going to multiply -2 times row 2 and add it to row 1. Right here for row 2 and row 3, we already have 1s. But if you notice, both are positive, so I need to multiply -1 times row 2 and add it to row 3. And here's my work. There's -2 row 2, right? So it's going to give us 0, -2, 2, and -4. And then when you add it to row 1, we just bring row 1 over. And it's going to give us 1, 0, 1, 2. That's my new equation number 1, or row number 1. -1 row 2 will give us 0, -1, 1, and -2. And we add it to row 3. It's going to give us 0, 0, 1, -1. That's my new row number 3. If you notice, right, I already got the zeros for the first part. I already got the 0 for the second part. Now, step 3, we're going to use row 3. It stays the same. So the 1 on the first row, third column, must be a 0. And also the -1 on the second row, third column, must also be a 0. And we have to use row number 3. I mean the 1 here. So this is positive, and the 1 in row 1 is also positive. So I need to multiply -1 times row 3 and add it to row 1. And since the -1 in row 2 is already a negative, and here we have a positive, all we have to do is add these two equations, which is row 3 plus row 2. And here's my work. So we have -1 row 3 will give us 0, 0, -1, 1, plus row 1. The result will be 1, 0, 0, 3. That's my new row 1. For row 3 plus row 2, it's going to give us 0, 1, 0, 1. That's my new row 2. If you notice, I already solved it because all the 1s are diagonally are 1s and the rest are zeros. So the solution will be 3, 1, -1. That's my answer, guys. Hey, guys, why do I there are some students that if you're taking the math 1325, and I believe the chapter 7 is optional, and other instructors do cover it. And I believe it's like like programming, and you have to use the Gauss-Jordan method. That's why I always include it in my 1324 class, because to assist the people that are going for business or for accounting, because they have to take the 1325. If you're taking the 1314, right, but this is not 1314, but for the people taking 1314 and they're going for math engineering, they will see this again in future courses. Okay, so it's crucial for this to be explained and gone over in this 1324 because students will be able to use it when they get to 1325. Okay, now how do we use this in real life? Okay, here we go. Okay, so we're going to set up 3 equations. Again, people with people and money with money. So we're going to let x equal to adults, y equals to teenagers, and z equals to preteens. And there's 570. So the first equation will be x plus y plus z equals to 570. Now comes money with money. So the adults, right, are $5, and the adults and x represent adults, so that's going to give us 5x. The teenager tickets are $3, and y represents teenagers, that's going to give us 3y. And preteens, right, are $2, and preteens are represented by z, so that's going to give us 2z. And what's the total income? Well, receipts is 1,050. So it's going to be x plus 5x plus 3y plus 2z equals to 1950. I got equation 1 and I got equations 2. How do we solve equation 3? Equation 3 will always be the hardest one with these type of problems, okay? Because we have to see, right, the second to last sentence is where the key words to represent equation 3. Right, 3/4 as many teenagers as preteens attended. This is how it's supposed to be set up, guys. Okay, by the time this is kind of hard to get, right? It's kind of confusing. Why is it y equals to 3/4z? As I tell my students, if it is difficult, write it how it sounds and then switch it. Okay, doesn't teenagers, right, represent y? So doesn't it sound like 3/4 y teenagers equals to preteens, which is z? Doesn't it sound like 3/4 y equals to z? It sounds like that, right? But then you switch it. What I mean by switch, you send the 3/4 with a z. That's a way that I have of trying to explain this, because at times it's kind of hard for the student to understand how this is the correct form, because it sounds like if it's 3/4 y equals to z. Okay, so this is the easiest solution that I came up with. Okay, now, right, you don't want fractions, so you're going to multiply both sides by 4. And then you're going to subtract 3z to both sides. Right, because we want it in the form ax plus by plus cz equals to d, right? And that's my new equation 3. So these are my equations, right? Now I believe on the next slide, I solved it, but I didn't use the Gauss-Jordan method because that's a little bit challenging. So I'm going to stick to the method that I did how to solve these by using equations 1 and 2 and 1 and 3, and getting rid of the excess, right? So that's the method that I'm going to use. So here, guys, I'm going to get rid of the excess. So multiply equation 1 by -5. After I do that, this is my result, right? Then equation 2, we just slide it over. So it's going to give us -2y minus 3z equals to -900. Now I'm going to get equations 1 and 3, right? But equations 1 and 3, if you notice, there's no x term. So we can skip that step. So equation number 3, right? That'll be my new equation 3. Right? It'll be the same one. Now here, guys, I'm going to get rid of the y's, right? So I'm going to multiply the first equation, or equation 2, by 2. So after I execute this operation, it's going to give us -4y minus 6z equals to -1800. So we just bring over equation number 3. So it's going to give us -9z equals to -1800. We divide by -9, and we solve. We got the value for z, which is 200. Now I go back to either equations, right? So this is my format here. But you can go back to the new equation 3 or the new equation 2 to solve for y. But I just did it this way. I'm going to go back to equation 2 and back substitute. I know that z is 200, so I'm going to plug in the 200 for z. So -2y minus 600 equals to -900. I'm going to add 600 to both sides. So I got -2y equals to -300. Divide both sides by -2. And the result will be 150. I have the value for y, I have the value for z, right? So now I go to equation 1 and plug in 150 for y and 200 for z, right? So then I subtract 350 to both sides, and I found the value for x. So what's my answer? 220, 150, and 200, right? But the x represents adults, the y represents teenagers, and the z represents preteens. We have 220 adults, 150 teenagers, and 200 preteens. That's my solution. Okay, now we're doing 6.4 now. Now, this is perform the indicated operation, right? So this is a 2x3 matrix, a 2x3. I believe I did some of these last week. 2x2, and this is a 2x2. So in order to add and subtract matrices, the matrices might be the same size. If we notice, matrix A is 2x3 and matrix B is 2x3, so we can execute the addition, right? We can add them. So it's going to be 5 plus 2, negative 1 plus 0, 6 plus 1, 3 plus negative 3, 4 plus 1, and negative 2 plus 4. So the result for A plus B will give us 7, negative 1, 7, 0, 5, and 2. I guess if you want, you can skip this middle step here. All right? You can go straight, like saying 5 plus 2 is 7. Negative 1 plus 0 is negative 1, and so forth, right? But I just show this step so you guys can know exactly what's taking place. Okay. Now, what's C plus D, right? Can we add C plus D? Yes, we can, because they're both a 2x2 matrix. So again, 3 plus 2, 1 plus negative 1, negative 5 plus 8, and 0 plus negative 6. That will give us 5, 0, 3, and negative 6. That's my result for the solution of the matrix C plus D. Now, can we add C plus A? I don't know. Are they the same size? C is 2x2 and A is 2x3. So this is not possible because they're not the same size. Okay. Now we're gonna be doing subtraction, right? So it's gonna be the same matrices as before, but instead of addition, it's gonna be subtraction. We do the same process. Negative 1 minus 8, negative 3 minus 0, 2 minus 1, 2 minus negative 1, 2 minus 3, and negative 1 minus 4. So it's going to give us negative 7, negative 3, 1, 3, 2 minus 3 is negative 1, and negative 1 minus 4 is negative 5. That's the result. Let's do one more. Let's do C plus D, or C minus D. So 5 minus 2, 1 minus negative 1, negative 4 minus 9, and 3 minus negative 7. And here's the result. It's going to give us 3, 2, negative 13, and positive 10. That's the result of subtracting matrix C minus D. And again, can we do A minus C? A is a 2x3 and C is a 2x2. It cannot be done because they're not the same size. Not possible. Okay. Now we're going to multiply the matrices. And I believe, again, I went over some of these concepts last week. So this is called like a scalar. The negative 4 is a scalar. If you have negative 4 times matrix A, it will be the same thing, like multiplying negative 4 times this is called every element in matrix A. It will be negative 4 times negative 2, negative 4 times 0, negative 4 times 5, and negative 4 times 3. The result will be 8, 0, negative 20, and negative 12. Now let's do part B. We have 5 times matrix B. Now this matrix B is going to be 5 times 0, 5 times 2, 5 times 4, and 5 times negative 6. And the result will be 0, 10, 20, and negative 30. Now we're going to do part C, which is negative 4A plus 5B, right? we already did negative 4a, which is A, right? And we already did 5b, which is in B. So all we do is going to put them together, right? We have the negative 4a in blue, and we have the plus 5b in red. And again, right, these are the same size. So it's going to be 8 plus 0, 0 plus 10, negative 20 plus 20, and 12 plus negative 30. So it's going to give us 8, 10, 0, and negative 42. That's my result. Okay. Now we're going to go to section 6.5. We're going to mark up a matrix product. Multiply matrices, right? In order to multiply them, the two numbers in the middle must match. For example, B is a 2 by 2 and A is a 2 by 3, right? The two in the middle match, so yes, it can be done, right? So yes, we can do the operation. And the answer will be the outer times the outer, the 2 by 3. Okay. So here, guys, step 1, let's put the matrix B, which is 1, 0, 4, negative 2. Let's put matrix A. So why are these colored? Because I'm going to multiply the first row on the first matrix times every column. So my first step is to multiply the first row times the first column on the second matrix, then the first row times the second column on the second matrix, and the first row times the third column on the second matrix. Okay, that's why what I'm multiplying is going to be in blue and in red. So it's going to be 1 times 2 plus 0 times 4. The result will be 2 plus 0. The answer is 2. So 2 goes in the first slot there. Boom. Now comes step 2. So now I'm going to multiply times the second column. 1 times 0 plus 0 times negative 2. It's going to be 0 plus 0. The answer will be 0. So the 0 goes on the first row, second column. Now we do the step 3. Right? We should need to go one more column to go. So we're going to multiply times the third column. That's why it's in red. So 1 times 5 plus 0 times negative 3. It's going to give us 5 plus 0. The answer is 5. So 5 goes on the first row, third column. If you notice, right, I already multiplied the first row times every column. That's why now for step 4, we go to the second row, which will be in blue. And we repeat the process as we did in step 1. We're going to multiply the second row times the first column. So 4 times 2 is 4 times 2 plus negative 2 times 4, which will give us 8 minus 8 will give us 0. The 0 goes on the second row, first column. Step 5, right, we repeat the process. It's going to be 4 times 0 plus negative 2 times negative 2. The answer will be 0 plus 4. The answer is 4. So the 4 goes on the second row, second column. And lastly, we got step 6, right? So I'm going to divide the second row times the third column. So 4 times 5 plus negative 3 times negative 3 times negative 2 will give us 20 plus 6 will give us 26. So it goes on the second row, third column, and that's my solution. Okay, that's my answer. Now 6.5 also, we're going to do inverse. Okay, let me see here, so you have about 5 minutes. Because for the inverse, this is one method, guys. For a 2 by 2 matrix, I'm going to multiply the matrix. It's going to be the matrix times the identity. The identity will be 1, 0, 0, 1. So we're going to use the Gauss-Jordan method. Okay, right, which means it's going to look like this at the end. Okay, now that's my inverse over here on the right side. So I'm going to the 4 has to be a 0 and the 2 must be a 0. So first, step 1, I'm going to multiply negative 4 times row 1 and add it to row 2. If I do that, right, this is my work here. Negative 4 times 1, 2, 1, 0. This is what we get, negative 8, negative 4, and 0. And when we add it to row 2, it's going to give us 4, 6, 0, 1. If you notice, it's going to give us 0, negative 2, negative 4, and 1. So that's my new row 2. Now, with row 2, I need to eliminate the 2 on the first row. So that row's got to change. We keep row 2. So now here's my work, right, which is Adam. He's going to give us 1, 0, negative 3, 1. That's my new, right? So this is my new row number 1. If you notice, right, these two has to be 1s. And we notice the negative 2 is not a 1 on the second row, second column. So we need to make it a 1. We're going to multiply negative 1/2 times row 2. After we do that, this is my solution. You see, guys, so this is my inverse. Negative 3, 1, 2, negative 1/2 is my inverse. Now, there's another way to get the answer. The very same thing, but it only works for a 2 by 2 matrix if you use this the formula. So the inverse is going to be 1 over, you multiply across A times D minus B times C. And then the A and the D switch places, right? The A and the D switch places, and the B and the C location, you switch the signs. So remember the matrix from before, right? The very same matrix. So let's apply the concept. It's going to be 1 over 1 times 6 minus 2 times 4. Remember the 1 and the 6 switch places, and the 2 and the 4, you switch the signs. Now we simplify. 6 minus 8 will give us 2 on the bottom right, so we're going to give us negative 1/2. If you multiply times every entry, it's going to give us negative 3/2, 1, 2, and negative 1/2. This was the inverse from before. You can only apply this method if it's a 2 by 2 matrix. Okay. Now this is how you plug into the calculator. Okay, you're going to go to second matrix. Then you're going to write the key is, that's the key where it says matrix. You enter. You're going to go to edit. You enter, and then you enter the size of the matrix and the entries. After each entry, press enter. Then go second quit. So your screen should be blank. Okay. Now, if you're summing the systems, then you're going to go against second matrix. You're going to go down to math. You go down to RREF, right? And then you enter, and then you go get the matrix. I mean, whatever matrix it was. Choose a matrix being solved. Say it was matrix A, right? So you enter matrix A, right? If it was that one, you close parentheses, and this, and then you get the answer, right? Then you get the answer. If it was a 2 by 2 matrix, this is what you would see. And if it was a 3 by 3 a 3 by 4 matrix, you will see all ones across, the rest zeros, and it'll be A, B, and C. Now, if you want to store the matrix to say to multiply by a matrix, all you do is repeat process from the beginning to enter additional matrices. Be careful, do not use the same location to enter additional matrices, and scroll down to use other locations for additional matrices. And then you'll be able to add them, subtract them, whatever you want to do. Okay. Okay, now I believe this is the last one here. Let me see, we got it's barely 12. Okay, now, hey guys, this is another way to solve the matrix. Okay, let me show you what it means. You need to find the inverse of the matrix A and multiply it by B. So say they give you this equation here. Okay, that's matrix A. Then the inverse, right? Well, I mean, will be here's a formula as before. So in this case, guys, if we plug this matrix in the calculator and we apply this concept here, or else we go, once we put this matrix and we go to second quit, right, and get the matrix, and we put this key here, the inverse, that's the inverse. Okay. You can do the work by doing it this way, or you can plug it into the calculator. So this is the inverse. X equals to the inverse of matrix A times B. Okay, that's the inverse. That's matrix B. So here, guys, I'm going to multiply 2 by 2. This is the 2 by 1, so it can be done. And the answer will be a 2 by 1. So I'm going to multiply 5/3 times negative 3. Right? 5/3 times negative 3 will give us negative 15 over 3. Then I'm going to add it to negative 2/3 times 5 will give us negative 10 over 3. If we do the operation, it was going to give us negative 25 over 3. That's my first look. Now I'm going to multiply negative 1/3 times negative 3. It's going to give us 3 over 3. And then plus 1/3 times 5 will give us 5 over 3. So it's going to give us 8 over 3. So this is my solution. You can follow the work, how we did the previous work, right? When I multiplied the first row times the column. But here, guys, there's only one column. That's why, I have to show no work, because all I do is multiply the first row times the column, and then the second row times the column, and here's my work. So that's my solution for X. This is the last problem for today, guys. I believe it's already 12:03, but I can do this in about a minute or two. Here's how we apply that concept. Okay, it says the budget truck rental charge $19.99 per day plus $59 per mile to rent a 12-foot moving truck in Austin, Texas in 2016. The total bill for your move was $86. The rates for a local moving company were $10 per day and 95 cents per mile. And the bill for the same trip, the same number of miles and the same number of days, would have been $94.10. How many miles and how many days was in the trip? Okay, well, let's solve that. So X equals number of days and Y equals number of miles. Equation 1, right? So it'll be $19 per day, 59 miles, and the total was $86. So that's my first equation. 19.99x plus 0.59y equals to 86. For equation 2, it's going to be $10, 95 cents, and the total was $94.10. That's my new equation number 2. 10x plus 0.95y equals to $94.10. You can solve this by the addition method, right, by the matrix form, but here's another way to solve it. It's going to be AX times AX. So my A is 1999, 0.59, 10, and 0.95. My X is going to be just X and Y. My B is going to be 86 and 94.10. Now we get the inverse of A, right? So the answer will be X equals to the inverse of A times B. So use a calculator to find the inverse, right? And round to two places. So if we get the inverse of A, it's going to give us 0.073, negative 0.045, negative 7.764, and 1.527. And we multiply it times B. Right, so I'm going to multiply negative 0.073 times 86, negative 0.045 times 94.10. And this, well, anyway, after you do the operation, this should be my result. Okay, because if you multiply, again, 0.073 times 86, and negative 0.045 times 94.10, and we add them, it should give us 2. Then we multiply negative 0.764 times 86, and 1.5227 times 94.10, and we add them, it should give us 78. And that's how we got the answers. I believe that's it for this PowerPoint, guys. So it was 2 days and 78 miles. So the trip was 2 days and 78 miles long. But that's how we apply this method of solving for this type of problems. I want to thank you for staying, guys, up to this point. I know I went a little bit over, like 6 minutes, but hopefully everything makes sense to you guys. Thank you.
Thank you, Mr. Zassi. Thank you, guys, for staying. We wish you good luck in your course. Now, next week, we won't be having Happy Math Hour because EPCC will be closed in observance of Veterans Day. However, you can come and join us again next week on, not next week, but the weekend after that, on November 17th, where we'll be covering linear and nonlinear systems in Math 1314. And in Math 1324, we'll be covering sets. And then in the 1 o'clock session, we'll be going over depression with the Emergence Health Network. Thank you all for coming today, and I hope you have a wonderful weekend.